So let's go check it out. Let's see. This will be a tougher, I can tell already. With the toboggan login problem solved, you set off towards the airport. While traveling by toboggan might be easy, it certainly is not safe. There's very minimal steering and the area is covered in trees. You will need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. You can make a map, your puzzle input, of the open squares represented by dots and trees represented by hashes. You can see, okay, for example, and then we have a tree here. These aren't the only trees though, due to something you read about once involving arboreal genetics, okay, and biome stability. The same pattern repeats to the right many times, okay. You start on the open square in the top left corner and need to reach the bottom. Can only follow a few specific slopes. You opted for a cheap model that prefers rational numbers. Okay, starting by counting all the trees you would encounter for the slope. Right 3, down 1. Okay, I don't get that yet, but let's continue. From your starting position at the top left, check the position that is right 3 and 1 down. Then check the position that is right 3 and 1 down from there. Okay, so like a chess moves thing. Just a pattern move, okay? And from there until you go past the bottom of the map. The locations you check in the above example are marked here with 0, where there was an open square, and X when there was a tree. The locations you check in the, okay, yeah. In this example, traversing the map using this slope would cause you to encounter 7 trees. Starting at the top left corner of your map and following the slope, how many trees would you encounter? Oh, that's easy. Okay, I think the next part will probably be what the best pattern is to use, but hey Yummy Bramras, thanks for joining. Okay, so important of this part is that you have to repeat the blocks, so you have to count the lines and then mod that, so you can just keep adding. So yeah, that makes sense. Let's check the input. I've written something to get the input. I've got that fixed now. So let's just make a day 3. Day 3. Okay. So let's do const char empty equals dot tree equals hash. Okay. Int trees is 0, empties also 0. Get input for day 3. For lines is that dot split. Okay, and we do read only int. Oh no, that doesn't matter here. Int width equals lines 0 dot length dot length. Am I crazy? Does it count? Wait. The 2 numbers here needs to be removed. Dot length. Okay. So this will be the number that we mod by this width. Okay. So we can say trying to go down blocks matrix size. Okay, so we can do lines length, and we do matrix size will be width, and it will print out a bit about the dimensions. So we do for int row is null, row smaller than lines length, and just int rows is lines length. It's not dynamic, so you don't need to check that every time. Okay, and now we do pattern int pattern right, and it's also a const actually. Const int pattern right is 3, pattern down equals 1. So we also keep track of the current int the row is automatic, so call equals 0, that's a starting call, and this should probably actually plus is pattern down. So did he check the first or not? No. Okay, so we immediately start going down. So we start actually on pattern down and not on 0. And we do call is call plus pattern right mod width. Actually, I think if call larger or equal to width, call min is width. I think this is better. So now we keep wrapping, speed running through the trees. Yeah, I'm trying. So now we do var, so we can have a data of or a row. Let's see. I'm just thinking about how to do this efficiently, but we don't have to reference it many times, so it doesn't matter. So we can just say lines row call. I'll just cache it anyway. Char hit. Let's just leave it like that. And we'll do hit is this. If hit equals empty, we do empties. Else if hit equals tree, trees, else throw new application exception should not happen. Okay, and now we can just say return trees, console right line empty trees, so trees empties. No, that's not empties. Okay, let's see what happens. I need to execute that. Day 3. $156. How many trees? 156. No, come on. And now we need to wait 30 seconds before I can submit again. See? Damn it. A minute. Spotted a small bug, I think, but it might work anyway depending on the input. Okay. Curious to hear that. So I have to wait a minute before I can submit again. I think it's all correct, but what do you think the bug is? Come on, I hate this. Waiting a minute takes forever. 17 seconds. Okay. Yay, that's the right answer. Continue to part 2. Okay. We'll talk about it after part 2 is done. I'm curious to see what you think. Time to check the rest of the slopes. You need to minimize the probability of a sudden abrupt stop after all. Okay. To determine the number of trees you would encounter for each of the following slopes, you start at the top left corner and traverse the map. Okay, so I just do this 3 times, multiply together. Okay, that would be a very big number. Okay, so let's do that. So we go to day 2, part 2. Part 2. And we go here and we say list int right, int down, patterns is new blah. And we do 3,1, 5,1, 7,1 and 1,2. Okay, so since I've already taken everything into account, this should be easy. So I just need to go for each var pattern in patterns. That's the benefit of setting it up like this. Now I can calculate a list of hit trees. So I can do list int results, come on, results equals new blah. And now I can say for each Now I can do results.add trees, return some trees, and we can do results. Okay, does this actually work? You need to multiply them. So, okay. Okay. I can just keep a running total. So long result is null. Actually, no. We start this as 1. And we just do result times equals trees. Results. Let's see if it stays within a normal result range. So this becomes a long. So this will be pattern dot down, pattern dot down, pattern dot right. Okay, so if I run this now, it should actually work. Okay, need to make sure that I remove the dots from the input. Ow, your number is too low. Okay. Okay, I messed something up. The number is too low, it says. What did I do wrong? Besides splitting this every time, which is stupid, but we reset this every time this gets reset. This should be good. Reset the trees. I reset it. The set multiplier, right? Am I? So we have 1, 5, 3, calc. You have 156 times 85 times 82 times 41. Yeah, so that's not the issue. Did I get all the input? Let's see. You need to minimize the number of trees you would encounter if each of the following slopes. You start at the top left corner and traverse all the way down to the bottom. Yes. Oh, I forgot to add the first one. I'm an idiot. I didn't add the first one to the list. So that's just a 1.1. Stupid me. Damn it. See, and that's like... Yeah, that's it. Okay. No, the code was perfect. It's just I forgot to add one of the inputs. Yeah. This was still, I thought it would be more difficult. This was still an easy one, but yeah, I really, I love Advent of Code so much. Because when I see this, I have flashback to the parallel worlds problem from last year, etc. And yeah, those were very hard. This one was very easy to do. I expected like you have to find the optimal path down the slope, something like that. So maybe that's something we'll see tomorrow. Or that you have to keep track of all these markings and have like 10,000 iterations and find the optimal path for that and stuff like that. So that's usually the kind of stuff that they do with Advent of Code. They keep increasing, increasing, increasing. So yeah, how many people solved it already? 16,000. Damn. Ah, Jonathan is climbing nicely. Expect him to be in the top 10 soon. Let's see, personal stats. Yeah. Oh, I actually, the thing is only the top 100. Yeah, these are so short, but they get longer as time goes on. So the deal with the score is only the first 100 people actually get points. So the first 100 people to submit every day after the puzzle unlocks, they get points. And since I always start like 2.5 hours late and most problems get solved in minutes, I'm never getting any points. But yeah, this gets way more difficult later. So for instance, if you go to last year, 2019, that's 1919, not even 2019. Let's see. There's like an int code computer. This was the challenge that I couldn't do. The many worlds interpretation. So here you have, yeah, it's so complicated, but basically you have to parse this as a kind of maze, and it has every time you exit, I can't even remember, but it was like it had keys and it would jump to like theoretical other planets that would be larger and smaller in size and stuff. Yeah, it's a lot of fun. But we had to write like an int code compiler for this year. Yeah, an existing int code computer. So we actually programmed like a virtual machine. And we get inputs that had to run code. So let's see, get your puzzle input. So this would be the input, and this would all be like opcodes of a made-up CPU. So you'd have to implement all these opcodes and features, and every other day you get like extra stuff to add. So it was really cool. So at least I liked it a lot. Some people really didn't like it because it can be kind of tough, but once you wrap your head around it, it gets really cool. So if you're into this stuff and you really like this, I would say go back to 2019 and check out the encode stuff. That was really fun, and it's like in steps, right? So it gets explained here. So basically, this is the first spec for the encode computer, but they keep adding and adding and adding and adding. So like you have like local jumps and full jumps in memory. It's really fun. And if anybody's having any issues, first of all, let me just drop the link to Advent of Code for those who don't know. And for other people, if you have any issues, you can always just come and ask. Let me get a link. Let's see, does this expire? No, I think this is okay. So you can always hit me up on Discord if you need help. So it's been fun having everybody here. Thanks for joining, and see you tomorrow, I guess. By the way, I will also be uploading these to YouTube with small edits. So I've uploaded yesterday and today. Okay. And I also try to add like small explanations for some of the stuff that's going on. So if you're having trouble or want to follow along here, you can just check out the YouTube as well. Let me just link that as well. Boom. Hi, I'm Nick, and I've just finished editing this video. I hope you like what I did with it. I tried to add some explanations where possible. So if you like the video, please like and subscribe, leave a comment, and maybe see you tomorrow. Bye bye.